All right, this is section 9.3, the law of cosines. The law of cosines, the birthplace of the law of cosines is the Pythagorean theorem. If you'd like to see the proof of the law of cosines, it is on page 693 in our book. And the law of cosines basically is for two cases for solving triangles. The first case is side, angle, side, and the other case is side, side, side. So you don't even need to know any angles to figure out. Oh, class is over. You don't even need to need any angles, and you can figure out the angles where the law of sines won't do that. So these are the two cases where it works. The formula looks kind of complicated, and you can kind of see how it's related to the Pythagorean theorem. So that looks kind of Pythagorean theorem-y, doesn't it? Like a squared plus b, or well, a squared plus b squared equals c squared, but you have to make this adjustment right there. So you subtract 2 times those sides and then cosine of c. So here's how I remember this. Whatever side is here, then that angle is there. So the b, it goes with angle b, and side a goes with that. So basically, I don't really look at these. I think more in terms of side, angle, side, and side, side, side. I would like to work with the triangle that we were working with in section 9.2, and we don't have to worry about the weird ambiguous case where we have the inverse of cosine is going to give me the wrong angle. So it'll work here. Oh, before I start plugging away at this, I was doing some calculus problems with my calculator here, and I was doing some calculus problems with my calculator here, and I changed my mode. So I'm going to go back to degree mode, so that way we won't get weird answers coming out of this. So I don't have to worry about inverse cosine being the wrong answer. Remember, inverse sine produces values between negative pi over 2 and pi over 2, or from negative 90 to 90. But inverse cosine produces values that are between 0 and pi. So we don't have to worry about the angle being too small. If the angle needs to be 140 degrees, it'll be 140 degrees. So we don't have to worry about it being the wrong angle. So there's no, this is actually easier, even though the formula looks more complicated. Okay. So the other day in section 9.2, we worked with this triangle right here, and we knew this was 30 degrees, and we knew that that one gave us the wrong answer of 100 and something. So let's go ahead and find that this is 30 degrees. So what you want to do here is, so right now it's side, 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 and we're going to find this angle, and that's going to be 30 degrees. So the angle and the side are the ones that you kind of focus on. So the angle and the side. So the side goes first. So 11 is squared is equal to, now these get squared, these are the leftover sides. So again, you want to focus on the angle and the side that you're after. And that goes with the formula here. Where'd my little formula sheet go? So it's all about focusing on the side and the angle. So each formula does that. And it doesn't matter even what A, B, and C are. Just focus on angle and side, angle and side, angle and side. So we're focusing on angle and side, and we're going after this angle. So then we do these squared. It doesn't matter. It's addition. So we can say this is first or that's first. It makes no difference. It's addition in between. So it's 15 squared plus 21 squared. And then we minus 2 times the product of these. And again, it doesn't matter which one is which, because it's 15 times 21 or 21 times 15. It's the same answer. 15 and 21. Okay, but what matters is the fact that you put the side with the angle. So we're going to do cosine of theta right here. So notice that the angle theta matches with the 11. That's what's important, and then everything else just kind of falls into place. Now we have to algebraically solve for theta. So I'm going to subtract this over, I'm going to subtract this over, I'm going to divide this over, and then I get cosine of theta. So I'm subtracting over, so it's 11 squared minus 15 squared minus 21 squared, divided by this answer right here. So divided by negative 2 times 15 times 21. That's a 21, not a parentheses. And that's equal to cosine of theta. Now I just have to do inverse cosine of this ratio right here, and it'll tell me the angle, because that is a ratio, right? Two things are being ratioed. And if you do inverse cosine of a ratio, it tells you the angle, correct? So here we go. Just typing this in. I'm going to do left parenthesis 11 squared, which is 121, minus 15 squared, minus 21 squared, parentheses, divided by, parentheses, negative 2 times 15 times 21. Close your parentheses, and boom. All right, that actually looks really super familiar to me because I've been doing trig stuff for a long time. And I'm going to do inverse cosine on that because it's cosine of theta would be that ratio. So now I do inverse cosine. So I do inverse cosine, second answer. So that popped into there automatically. The answer key, remember, is above the negative sign down there. Enter. So 30.1 degrees. Now I said it was 30 degrees because I was rounding. So that really is 30 degrees. Because I had to make a choice here. Was I going to round? I use whole numbers, so that's technically not exactly 30 degrees if those numbers hold. It's really 30.1 degrees. It's a little bit above, but we're going to call it 30 degrees. Now, this angle here, remember that angle was a bugaboo. It would not tell me that angle. It told me like it was 70 some degrees, but it was obviously an obtuse angle. It was over 100 degrees. So I'm going to call this alpha. That one was theta. I'm calling that one alpha. And so then remember how this works. If you're focusing on these two things, right, that's what we're going to put down first. So this comes first. 21 squared is equal to, then these two are the leftovers, right? It doesn't matter which one you put first because it's addition. 2 times those two. It's 11 times 15, and then cosine of alpha. So now I'm going to subtract this over, divide that over, and then do inverse cosine. So let's go ahead and start typing that in. So it's 21 squared, and then I'm going to subtract off the 11 squared, which is 121, subtract off 15 squared, and I forgot to put my parenthesis in there. So I'll go back and insert it in parentheses. If you forget to insert something, it's above delete, of course, so you hit second insert. All right, and divided by this negative thing right here. So divided by left parenthesis, negative 2 times 11 times 15. Close the parenthesis, enter. So it gave me a negative answer. That makes sense because that's really big. You subtract the two things off of it, and it's going to be positive. And then you divide by this negative, so it'll be a negative. That's the ratio. Inverse cosine would be the answer. So I hit second inverse cosine, and then second answer. That copied and pasted that in there. And it's 106 degrees, which is what we figured that out to be the other day on the other video. So it didn't tell me that it was 76 degrees. It told me that it actually told me the real answer because inverse cosine gives me back answers between 0 and 180 degrees or 0 and pi versus inverse sine. So I don't have to worry about that weird ambiguous, there's two solutions or anything. So the formula looks more complicated, but it actually, we'll call this 107 degrees, rounding to the nearest degree. So then we can know what this side was right here, or this angle right here. What if we wanted to know the missing side? Let's go ahead and do this one more time. So that means and again, I'm rounding just to make it simple. These two angles would be 137, so we do 180 minus 30 and minus 107. So 43 degrees right here. 43 degrees. All right, so I'm going to get the calculator to tell me that this is 15. So I'm going to pretend for a second that this is x. I don't know what this is. So I'm going to do the law of cosine again. But this time I don't know the missing side. So this is the side angle side situation. So I have the 11 here, I have 43 here, and I have this. But again, we focus on these two. This is the focal point, and then those are the other things that just kind of fall into place. So this time I don't know what this side is here. So we could call that A, B, C, it doesn't matter. I'm going to call it x. So x squared is equal to, then these two come next, 11 squared plus 21 squared. And then subtract 2 times those. And then cosine of 43 degrees. So to solve this, I just type this all into the calculator, and then I just need to take the square root. So I can go ahead and do that right now. Let me get a different color. Take the square root of that side of the equation, take the square root of all that. So I just type that into the calculator. There's no solving to this as much as just taking the square root of this answer. And that should yield something really close, some close decimal to 15. Clear. 11 squared plus 21 squared minus 2 times 11 times 21. Cosine of 43. Enter. So that's a pretty big number, and I'm going to take the square root of it. Ooh, that's going to be really close because 15 times 15 is 225. So when I take the square root of this, I'm going to get something a little bit smaller than 15. Second square root, and then second answer. So I copied, pasted that in there, and 14.97, which I would round to 15. So there, in summary, here it is. It looks complicated, but just focus on the angle and the side. Angle, side, angle, side. And then those, there's a lot of freedom here because addition, it could be, you know, in either order. You could do b squared plus a squared. And then there's minus, and then don't forget the 2. And then you can multiply those together in either order because a times b is b times a. So there's a lot of freedom with the law of cosines.